Okay, so homework for today. Well, before I forget, um, just a reminder after class today is the CS get together. It's down the hall, so free food, and then there's good prizes with the whole quiz thing they do. Strongly encourage you if you haven't been to one before. Make sure you show up early. It usually starts right at 11:30, and they do one of those, meet and greet things where you got to go around and find somebody who wears the same size shoes as you. That kind of stuff to meet other students in the department. So while that's a good fellowship exercise, anyways, it's also your opportunity to get the best prizes. So if you do well in that, then you will have first dibs at some of the better prizes. I think there's an Apple Watch and iPads, and I don't remember what the other good ones were, but several prizes that are worth like $300 each type thing. Yeah, no, I mean Curcio has always done well with it. Um,
Or roadie.
yeah. So
That's in your class. Just talking about that.
so now's your opportunity. So, huh?
Isn't Cursor going to be here
Uh, I don't think so. It's only undergrad,
though? Oh, so he's not going to be here tonight.
right? Yeah, so you have an opportunity to get the good stuff. So I strongly encourage you to show up and participate in that strongly, uh, as well as get to know the other majors and minors in the department. I think that will be beneficial as well as the further you go in the department, the more you'll be relying on each other for study groups and things like that. So you might as well get to know people now. Okay. So homework for today was to teach a superstring how to sort itself, which may or may not be all that functionally beneficial, but for an academic exercise, it was interesting enough. So we have our superstring, and I think I mentioned that we're going to write a function called sort, and sort's going to put them in what's historically called lexicographic order, lexicographic order, which is Unicode in order by Unicode value. All right, so let's kind of do this a brute force approach first, then upgrade our sort to be a little bit better sort, and then look at even a better sort. We'll introduce recursion in Java. Okay, so we'll go ahead and write this guy. It'll be public void sort because we're actually going to, did I say we were going to return the internal sort? Here, I'll just move my thing down there. That way I can read what I asked you to do. That internally sorts the characters in the superstring in ascending order by Unicode value. Okay, so we are changing the internal state of our superstring, so we will not actually return a value. Okay, our return type will be void. So this is going to be public void sort. Doesn't need to take in a parameter because it already knows about the string that this superstring holds. All right, and our goal is to go through and create a new string that is the old string in sorted order. Okay, so if we're going at a brute force approach to this, just how do you sort something? If I put 5 or 6 letters in front of you and I tell you to put these in alphabetic order, what would you do? How would you go about doing that just as a person? Okay, so expound on that. You can just tell kind of thing. How do you tell?
You already know the order, so you kind of compare a letter to another letter and goes before it.
Okay, so you have 5 letters in front of you. What's the very first thing you do?
Take the first letter.
Do you pick the smallest?
Nice. Take the first one, I guess, and then compare another to it, and then start sorting it, I guess.
Okay, but in general, we're going to keep it at the high level, and then keep squeezing it down. The high level, if there's only 5 letters in front of you at a glance, can you pick the smallest? Yeah, so you kind of know the order, like you're saying. You kind of look across them and you decide, this should be the first of my sorted guys. So you lay him over the side. He's going to be in the far left, right? Then you say, okay, out of what's left, what's my next smallest, right? And you go and find the next smallest. Then out of what's left, what's my next smallest? So is a skill, might a helpful skill be find the smallest char in a string? That might be handy. Okay, so I'm going to give myself a little helper function here. We'll make this guy private because we're only going to need this internally. We're not going to make this publicly available to people using superstrings. We want this to be a little helper function we're going to have. So we're going to have a private char find smallest. Okay, and this guy is going to return the smallest character that it finds in that string. Okay? Now, find smallest, we would assume is never going to get called on an empty string. So we're kind of purposing this tool, we're building this tool with the understanding that, you know, it's solving our problem. Okay, so whenever we're writing functions, we kind of have a couple of options. We can decide, you know, I'm going to write this function so that it's very, very, very generic so that people can apply this to all sorts of types of problems, right? So that's when you know, if in real life you walk into Home Depot, you look at the shelves, you see all of these different solutions to common problems, okay? Now, on top of that, in real life, do we have kind of one-off solutions that are only really applicable to a very specific problem we're solving at home or something? Is that a thing? That exists, right? Maybe you've ever made a homemade funnel, like out of a piece of paper or something like that. Like I need to get this sugar into this container, and I don't know where the funnels are. I don't own a funnel, so you kind of make something that will allow you to more conveniently, we've all done that, right? Is that, it's like, who makes a funnel? You know, so sometimes our solutions are one-off type solutions. So what we're trying to do here, and this is kind of a tactic for, you know, my initial gut feeling is to say beginning programmers, but it's not just beginning programmers, it's really all programmers. When you have a problem that is somewhat big, you can come up with this really complicated algorithm to do all this stuff internally, and sometimes that gets complicated. Okay? It gets complex, and you might be prone to errors. Now, sometimes when performance does make a difference, you might need that complexity. That might be a kind of an important part of it because you don't want to trade off too much speed at the cost of you know, making it convenient to implement. But since our computers are so fast, is it a fair statement to say that most of the time as a programmer, we don't need to come up with the most efficient solutions as long as it's a correct solution? Does that feel like a correct statement to you? Our computers are fast, right? So especially from a beginning programmer's perspective, but also from, you know, any programmer's perspective, it's important for us to break problems down into their smallest pieces. So as I've kind of approached this problem, I mentioned, well, what's the very first thing you do? You find the smallest one, right? So if we have a string and I say pick out the smallest, how do you do that? So you mentioned maybe grab the first one, and then you compare it to the second one. And if the second one is smaller than the first one, we put the first one down and pick up the second one. We're going to always hold on to our winner, right? So at the end, once we've compared it to everything, whatever we currently have in our finger, I'm kind of thinking it's like Scrabble pieces, right? Okay, whatever character I currently have in my finger, that is the smallest of the characters. And that's the guy I'll return. Okay, so find smallest is going to return the smallest character. Now, we are only going to call this guy if we have characters to return, right? So this is a one-off. This is our special purpose funnel type of problem. We don't necessarily need to ask that question whether or not I have characters to actually return. So what I mean by that is our internal string, this.s, that guy is going to have a length. Now, let's assume his length was 0. What character would we return here? What's the smallest character in a string that has no characters in it? Is there a good answer to that?
\0, the terminating character.
Okay, I suppose you could return that. I'm actually not sure that Java supports the terminating character. \0 is how arrays were implemented, and really strings were implemented in like C, very old languages. So just generalistically speaking, is it fair to say that there's not a great answer to that question? If I hand you nothing and I ask you what's the smallest value in this nothing, there's not a great response to that, right? Everybody okay with that? Now, the issue we have here, though, is Java wants us to return a char. In fact, Java expects us to return a char. In fact, if we don't return a char, Java's going to scream at us. So even if we ask the question, well, I'm only going to do this logic if this.s.length is greater than 0. So only go and figure out what my smallest character is if s.length is greater than 0. Well, even if I do a return a in here, for example, just haphazardly returned an a, notice that Java's still not happy. It's saying this method must return a value of type char. What do I do? So we kind of have two options. Two options we can do. We can either make the assumption that this is a special case, right? We make the assumption that this guy is a special case method that's only built for our problem. It's not going to be a generalistic solution that everybody could use for every single problem because we're taking some liberties with it. We know that we intend to call this guy only when we actually have characters defined. And therefore, because of that, we know that this guy doesn't actually have to check to see if there's characters in there. He can always assume that there's one character in the string. All right, so I can always just come in here and I can say char winner is equal to this dot char at 0. So I'll grab the very first character in there. Then I'll say for int I is equal to 1, I is less than this dot s dot length, I plus plus. So now I'll go through all the rest of the characters. I already grabbed 0. Now I'm going to start from 1 and go all the way up to the last legal element in the string, s dot length minus 1. And I'm going to compare my winner to each of those. And if any of those has a value that's less than my winner, I'm going to replace winner with that guy. So each time through, I'll ask the question, if this dot s dot char at I is less than winner. If I'm looking at something that is smaller than my current winner, then I'll say winner is equal to this dot s dot char at I. Update my winner. When all is said and done, I'll go ahead and return whatever's in winner. Is that a reasonable implementation for a find the smallest character in a string? With some caveats. Caveats being your string must have at least one character in it. Don't send me the empty string, otherwise I break. Where would this break? If I sent this the empty string, what would happen? Right at the first line, we get our program would crash, right? Because it's going to say, you asked me for bucket 0 of something that doesn't have anything in it. Therefore, bucket 0 is an array index out of bounds. It'll actually be string index out of bounds. You're trying to access a bucket of a string that doesn't exist. Error. Program crashes. Do not pass go. Make sense? So we would make the decision that this guy is special purpose for our use only because we know how that tool works. And we all have some of those things around the house, right? You know, I had we went to the hackathon 3 weeks ago or something like that, the one in Illinois. We had 2 cars that went, and the second car was driven by one of the international students, and it was a four-door car. You figure it could fit four people, right? No, he said, my car can fit three people. Like, well, you have four seats. Yeah. I know my car. It can fit three people. Apparently, there was some issue with the brakes or something like that, which didn't make anybody feel that comfortable, really. But anyways, it could fit three people because he knew the tool that he had. It had some caveats, right? Now that's okay. That's the car you could afford and all this other stuff. So that's what we rolled with. So punchline here being, it was interesting how many people wanted to pile into my car. The hopeful survivors went into the other one. So in any case, this would be a reasonable tool as long as we're the ones using it. Okay. Now, what if we wanted this to be more of a general purpose tool where it did catch that state, where it potentially could return a value that was, it potentially could try to return the smallest value of the empty string. Java has something built into it, as well as many newer programming languages, called exception handling. All right, so exception handling allows us to gracefully handle errors without having the program simply crash. So in that situation, we could actually handle the error, respond to it, and actually have the program keep going. So from a programmer's perspective, we have to make the decision. Is this a general purpose thing that we want to have work for anybody? In which case, we kind of want to make it bulletproof, right? That's when we start putting in all this error handling and exception handling stuff. Or is it a one-off thing where we know our car? Only throw this guy something that it can work with, that kind of thing. All right. So if we were writing this in the other way, so let me call we'll write a second version of this. So we're going to call this guy private char find smallest 2. All right, and we're going to say in here that this guy does something called throws. Actually, we're going to make this a little bit better. When we upgrade to the next level of exception handling, it becomes kind of a hierarchical approach where a function can throw an exception. Whoever's going to call that function has to try to use the exception. In fact, let me show that one now, and then I'll show you the more internal one. So I'm going to say that this guy throws an exception. Okay? So if something bad happens in here, what this function does is instead of returning a char, he freaks out and throws creates an exception and throws it up in the air. Whoever called me, you got to deal with this exception. That makes sense? But that gets me out of the problem of having to return a char. So if we kind of write it this way, we're going to say if this dot s dot length is equal to 0, then we're going to throw a new exception. An exception's taken a string. We'll call this guy 0 character exception. Something like that. All right, so our guy will yell and say, there's an exception, you have to deal with it. Now, we actually, through inheritance, could create our own special version of an exception. And I'll kind of talk about that more when we kind of get to that next piece of this. But we could create that, and whoever calls this could test to see if that particular exception occurred. Because you might, is it plausible that you might have a function that 2 or 3 different kinds of things could go wrong in, right? And depending on which exception it threw, you might want to respond differently. That would make sense? So with that in mind, you might want to have 2 or 3 different types of exceptions. Instead of, this is kind of our lazy exception approach here, where we just said, look, I'm going to grab the most generic exception we have, the exception class that comes with Java, and I'm just going to use that guy to scream a string. Here's my exception. All right, deal with it. So we're going to say that this guy is going to throw this new exception. This guy is going to be an object. Rather than stored in a variable, we're just going to go ahead and throw it. Comes out of there. If we get past this if statement, that means we can actually call our original find smallest, right? I'll just steal this logic just so we can, instead of calling that, so we don't have to have 2 functions that's self-contained. Okay, so now it's giving us a warning because we never actually use the function, but that's okay. We will use it. So now our find smallest 2, which we've advertised as potentially throwing an exception, can now optionally bail out right there by saying, look, if you give me something that has no characters in it, I'm going to go ahead and scream rather than going through useless logic. And then whoever calls this guy can choose to deal with that. All right. Otherwise, if I'm still kicking here, if I'm still alive at this line 113 right here, that means I did not throw the exception. And I can go ahead and do my normal logic because I know I must have at least 1 character in there. All right. So with that in mind, let's talk about the different ways we would call these 2, because there are different ways. So inside sort, if I wanted to find the smallest character, I would say char smallest is equal to this dot find smallest. And if I return if I call my original one, I'm okay like that. Now, if I say char smallest 2 is equal to this dot find smallest 2, notice that it's not so happy with me. It's saying that this guy potentially throws an exception. If I hover over that, it says unhandled exception for type exception. And it gives me a couple of options. I can either do a throws declaration or I could do a try catch. We're going to do the try catch right now. So we have 2 options here. We can decide we're going to handle that exception ourselves. We'll respond to it. Or we can play hot potato and just toss it to the next guy. Whoever called me is going to have to deal with this error. Okay, that's usually the lazy way of handling this as well. So where you just throws exception on every single one of your functions. And if there's ever an exception, you just keep tossing it up, tossing it up, tossing it up, and eventually your main method gets it and just spits it out to the screen. That's wasted exception handling, but you could potentially do that. So we can choose whether we want to deal with this exception ourselves or pass the buck. Okay, so what we're going to do here is we're going to surround this guy with a try block. We are going to try to do this stuff. Okay, and then we're going to catch a potential exception and respond to it. So, we could say system.out.println something went wrong. And actually, if you want this to show up in red, you could actually use, there's a second version of out called ERR. So in most modern operating systems, we actually have 3 I/O streams. We have a system.in I/O stream for reading in stuff that comes in from standard input, which is the keyboard. Then we have standard output, which is our system.out. And then we have standard error, which is system.error. And the purpose of having standard output, let me ask the question. Why is it beneficial to have both a standard output and a standard error? To have 2 different ways of getting stuff onto the screen, but actually have them coming from 2 separate sources. Why might that be beneficial? Potentially haven't given you enough information. You'd have to draw a decent connection there. What's logging? In our operating systems, do our operating systems have logs, like error logs and stuff like that? You know, what does that mean? Where we're keeping track of things that went wrong, or when tasks occurred, that kind of stuff. So somewhere we're kind of building on a document that has stuff in it. Well, specifically for error logs, if we have a program and the program has two different types of output. It has output when everything's fine, normal output, and then it also has output when things aren't so fine. That would be your error-based output. Would it be nice for error logging, for the task of error logging, for us to be able to easily identify which of the two that is? So we can then take errors and redirect them to this log file and then ignore the other thing. Does that make sense? So we can choose to only take this one output stream, which is system.error, and have anything that comes from that go into the log file and ignore everything from the other file as far as error logging goes, because that's not error stuff. Make sense? So that's kind of the purpose, and that's something that's left over from Unix from years and years and years and years ago, and it's still true today in our modern operating systems. Okay, so we'll go ahead and say system.err.println. Something went wrong. From our perspective, this works just like system.out, except Eclipse will make it show up in red. is what it'll do. All right, so our other one, find smallest. So here, let's just go ahead and test this real quick. I'm going to make both of these public just for the moment so I can call them from main. All right, so our two different find smallests. I'm going to go out to our driver, and I'm actually going to create a superstring that has nothing in it. And then I'm going to say s.find smallest. We'll call our first version of this. And this guy is going to crash. So exception in thread main, string index out of bounds exception, string index out of bounds, blah, 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 so on and so forth. That guy crashed. Unrecoverable. Now if I call find smallest 2, find smallest. Oh, I need to do the try catch myself here. We were calling it from within sort. I'm doing that in sort already, aren't I? We'll just do it out here. So now I can try to do this. I can catch the potential solution, or the potential exception. And I can say, let's try something else here. And then down here, I'll say system.out.println program continues. So we'll see that we actually survive. All right. And I'll go ahead and do system.err here just so you can see the difference. See, it shows up in red. All right. So I'm going to try to find the smallest 2. In this case, we know an exception is going to occur. And it'll say, let's try something else, but we will survive. And then we'll come down here and keep going. So let's try something else. Program continues. That make sense? So that allows us to deal with runtime exceptions in our program without our program completely bailing. Okay. And if I come in here and I put a string inside there, run this again, we see program continues because we did not hit that exception. So everybody get the kind of the purpose of exceptions? Now, I could actually decide to say that this guy throws an exception. Let's say main throws an exception, which then would let me do this. Now it's okay with me calling this find smallest 2, even though find smallest 2 throws an exception, because I'm inside of main. So from the context I'm currently living in, I've decided I just passed the buck. If any exceptions occur in here, I'll just toss them on to whoever called me. And who calls main? All programs begin and end with main. So who calls main? Before the OS, it's going to be the Java virtual machine. But something out of our control, right? We've removed, if we're doing it at the point of main, if we're throwing the exception, we've removed ourselves from the equation. Is what we've done. Program will crash because that's all main knows what to do. It's how they had to build it in there. If main gets an exception, it's going to spit it out and stop the program, which was just as good as us having the error to begin with. So I'll go ahead and run that. So we notice that the text is different because this is our version of the exception, the 0 character exception instead of that string index out of bounds default exception, right? So this is clearly our exception that we passed to main, and all main said is, what do you want me to do with this? Spit it to the screen, stop the program. Done. Make sense? So as a programmer, we have that flexibility to deal with these errors in different ways. Now, most beginning programmers, and honestly speaking, most of the stuff that we write as students, you're probably not going to do a whole lot of exception handling. But it's one of those things that's an important concept to know. It's probably an important concept to practice. We probably should use it more in our assignments than we do traditionally. But there's so much other stuff, so much logic practice we have to cover that doing all this extra error checking work sometimes gets in the way of the logic we're trying to practice. So at the very least, you see that there's tools that are embedded in the language for handling this. And throughout the semester, we will interject some stuff like this where it would make some sense for handling it. But for us here, we probably aren't going to do a lot of it for at least a lot of it very often. But we probably should. Okay. So questions about exception handling in general. We try to do something, we can catch the problem, and handle it, or we can throw it to the next guy and let somebody else handle it. If we keep throwing it over and over again, eventually it'll be the virtual machine that has to handle it. And our alternative would then be we can choose. Oh, I actually caught the fly. There's a fly runner, I was surprised and I let him go. But
still you caught it.
Yeah, how does that happen? It's probably just the you didn't expect to catch him. It's like remember Mr. Miyagi? Did you see those with the chopsticks?
Yeah.
Or is that just like now it's like legend, like lore? Well, Karate Kid came out before most of you were born, didn't it?
Yes. Yes. Supposedly they made a remake with Jackie Chan and Will Smith's son, but no one knows for sure.
Well, I saw the movie, so yeah, that one did come out, but yeah, it was a very different movie. It was not the same storyline.
No.
And then you had Karate? Was it Karate Kid? I think 3.
The next Karate?
No, 2. Karate Kid 2. No, still the original series, but when he went to China.
Yeah.
No, went to Japan rather.
Yeah.
And they had the little drum things with the strings on the side of them where you can go like that and it did the drums. You know what I'm talking about?
Yeah.
Yeah. So my brother and I went on a quest to find those. And I don't even know how we came up with this. We went to Disney World. We were on vacation going to Disney World, and we just decided that they must have those at Disney World. Just out of the blue. If I look back on it now, I don't know why that makes any sense. But they did have them there. And we broke it in like in a day. So, yeah, that was a wasted quest. Okay, so in any case here, I'll go ahead and leave my find smallest 2 in here just as an example of exception handling. But for us, we're just going to go ahead and use our specialized version of this so we don't need to deal with exception handling. We can focus on the logic of this. And we'll just make sure we always send it something that has characters in it. Okay? So I'll go ahead and, well, I'll take this out. So there's my char smallest. So now I know when I'm in here, and we're going to go ahead and we're going to say while this dot s dot length is greater than 0. As long as I still have things in my string, I'm going to grab the smallest element in my string, and that'll be inside of smallest. Now, when I get the smallest character in my string, has my string gotten any smaller? I have the string hello. I'm going to pull the E out of it. Well, I'm going to find the E. The E is my winner. If I look back at find smallest, does this guy right here in any way change the string hello? It just finds the smallest character. So after I got the smallest character, don't I also want to now go and remove it? Okay, so now I need to remove the first occurrence of that character. So have we already written something like that? I don't think so in this one. We've written something like it before. So now I'm going to go ahead and make this guy private again. Make this guy private again because we only needed access to it in here. We won't be able to call it from out here anymore. All right, so now after find smallest, I'm going to have another helper function called remove first occurrence, something like that. So private void remove first. I'm going to call it remove first found because I don't want to have to spell occurrence. Remove first found. It's going to take in a char C. All right, and what we're going to do is we are going to build a new string, which is the original string with every single copy, which is the original string with the exception of the very first element that matches C removed. All right, so I'm going to have a boolean here called found. And we're going to have this set as false. Now, previously, I've kind of given you a vocabulary word that kind of mentions a variable like this, a Boolean variable that gets set to a value, and then when we finally do something, we set it to something else. What did I call this kind of thing? So a variable that looks like this and works like I've described it would typically be called what kind of variable? This is more trivia knowledge, not overly important. It's called a flag. So this is going to be a flag variable. So as soon as we find the first occurrence, we're going to go ahead and raise that flag. That way we don't accidentally remove any other ones. Make sense? So we're going to go through, well, we're going to have a string for our answer. Empty string. We're going to build something onto a string. We're going to go through every single character in our current string. I is less than this dot s dot length. I plus plus. Then we're going to ask the question. If the character I'm currently looking at matches the character I'm trying to find, and I have not already removed one. So let's ask that question first, then we're going to invert that question. So if this dot s dot char at I is equivalent to the character I'm searching for, and this dot and found is equal to false, even though it's redundant. I think that makes the most sense. So if this dot char at I is equal to C, and I have not found this guy, I want to skip that character, right? I'm going to leave it blank for right now. I'm going to go into the else. Otherwise, if it's either not the character that I'm looking for or I've already found the character, I want to keep it. So I'll say answer is equal to answer concatenated with this dot s dot char at I. That makes sense? Now, if I did find it and it's the first time I found it, I definitely want to mark my found, right? This dot found. It's actually not this dot. Why is it not this dot found? Since I've already typed it twice, it's obviously an error people can make. Why is it not this dot found? Why is it just found? Why could I not say this dot found here? Say this again.
Is it because of the scope of
It is. Tell me more about that.
it's in the private function instead of the entire.
Okay, and what's this? So if I say this dot, what am I referring to? I'm referring to this particular superstring, and if I'm saying this dot, I'm talking about his fields, those variables at the top. So in order for this dot found to be a thing, I would have had to define him. It actually doesn't have to be at the top, but traditionally we put them here at the top. It would have had to be in my fields up here. That makes sense? I don't see something called found up there. So this doesn't own something called found. This local function here, where did I call it? Remove first found has a variable called found, so I just say found is equal to true. What were you going to say?
So, is there any way to get a value from a method that the method isn't returning? So, like, we aren't returning found, but would it be possible to call remove first found in such a way that we could get the value of found?
Well, internally, you could have remove first found, set some global variable, you know, and then have your other function check to see that. Alternately, you could have this guy return a value, since right now it doesn't return a value. So you're currently not using its return type. Is anything keeping you from returning the value of found from it? No. So then third thing is assuming it's a function that does return a value already, and you have a second value you'd be interested in. And this is actually a programming language thing. You're effectively saying, what if I want to have two return types, right?
Yeah.
What if I have a function that I want to return two different values? Based on what you know now, how would you do that?
Probably one would be setting a global variable.
What's a better solution than that? Do we happen to have any sort of tools in our toolbox that let us hold more than one value? Okay, arrays are typed. So an array would only work here if the two things you want to return, or even the more than two things you want to return, are all the same kind of things, right? An int or a char or something like that. Okay, so that solves the problem if what you want to return is more than one of the same kind of thing. But so now to take it a step further, you want to return more than one of different kinds of things. You might want to return a boolean and a string. Okay, so do we happen to have any tools in our toolbox that allow us to hold a boolean and a string, for example?
No, but we can make one.
Okay, so then the answer is yes, because we can make one.
Right, we can make a class.
Yeah, make an object. Make an object and have that object hold on to a string, has a string field, and also have a boolean field. And instead of returning the string or the boolean, have it return a new instance of that class that has the string and the boolean set to the values you wanted. Right? Historically, what was that called? We've introduced that concept. In C and C++, really C was the predecessor. Before we had objects, what was the predecessor to objects? Cat, dog, or structs? Structs. See, over the years, you start realizing you have very crappy audience participation, so you can't give too many correct sounding options. Yeah, so it's a struct, right? So what's a struct? A struct is a collection of name value pairs that aren't necessarily of the same type. So it's from your perspective, it's the upgrade to arrays. Okay. Now, this is another review, and this is an important concept for us to understand because it comes down to the pass by value versus pass by address thing. Hint, hint. So with that in mind, Java, when they came out with Java, they removed the existence of structs. Right? Now, you just mentioned that no big deal because I can create an object and choose not to put a bunch of functions in. I mean, we're writing functions all over the place here, right? But you could write an object and just have a couple of fields in there for the exact purpose you're talking about. I need to return something more than one value, and the values aren't all the same. And even beyond that, you might want to have meaning to those values. I mean, even if you want to return 3 integers, for example, okay, you could have a 3-bucket array. But now, why is a 3-bucket array, a 3-bucket integer array, worse than an object that has 3 integer fields? Okay, if I'm handing you 2 objects, you're expecting 3 integers from me, right? And I'm going to hand you a 3-bucket integer array with your 3 integers in it. Why is that not the best gift in the world? Why would it be better for me to give you an object with your 3 integers in it? What do those 3 integers mean? Let's just pick a real life example. Maybe it's a vector. So x, y, z coordinates. If I give you an array with the x, y, z coordinates in it versus an object with the x, y, z coordinates in it, why is the object better? Yeah, the object allows you to give meaning to the variables. We're going to have a int x, int y, int z inside the object. Over here, we're going to have, well, just remember that bucket 0 is your x, bucket 1 is your y, bucket 2 is the z. Don't forget that, because you screw that up, you're going to plot the thing in the wrong place. Make sense? So they're not equivalents. The object gives us an upgrade. Right? It allows us to attach meaning through the name of the variable to our fields. Well, in Java, they actually removed the existence of structs. Now, you've mentioned that we can kind of pull off a struct through a class without functions in it, right? But is it exactly like a struct? How's it different?
I believe objects are passed by address, structs are passed by value.
Yeah. So there is a little caveat that isn't a deal breaker for us, but it does change how we might need to problem solve with these guys. Historically, a struct was passed by value. When you passed a struct to something else, you got a copy of it. So if you modified the contents of that struct, it did not have global implications. Objects have always been passed by address. You change the contents of that object, it's changed, because you're modifying the memory address where that dude lives. So now I have an object that's acting like a struct. Really solves the same problem, but he's still an object, which means he gets passed by address, not passed by value like traditional structs are passed by. At the end of the day, this probably only really negatively impacts somebody who's been programming for a very long time and maybe has been working in a C environment for years and years, and that's kind of an ingrained thing for them, that I pass a struct, it's a copy. So if they wanted to have permanent changes, they need to then get the address of it. They need to take an extra several steps to change the actual memory value of that guy rather than the local value. They would actually take it as a parameter, a struct pointer, instead of the struct itself. Where in a more modern language, if you're using structs as if they are objects, using an object as if it was a struct, you now have that knowledge that it's being passed by address, and therefore any changes you make are permanent changes. You just have to change your mentality of how you're dealing with it. Not the end of the world, just the nature of the tool changes slightly, right? So just something to keep in mind. It probably will have a minimum impact on you in industry because it's not impossible, but most of you will likely not go and work in the C environment. A percentage of you will. I mean, it's still very much a living, tool, but it's not the popular tool today. Most of you are going to go and become Java developers or C# developers, maybe Python developers. You can go on the Apple side of things, do something in Swift, but that's probably a smaller market, not nearly as small as it used to be. It's a pretty huge market now, but relatively speaking, Java and C# is your sweet spot, which is why we focus on those languages here. Okay, so just kind of a interesting thing to add there. All right, so remove first found. We're going to take in a char C. So we got off on that tangent, but it was a good tangent, asking what if I need to return more than one value. Some modern languages actually have the ability to return more than one value. Swift does. C# in its newest iteration actually does as well. I would say that most programmers, though, do not leverage that. Most programmers, if they want to return something, they encapsulate it into an object. They have more control over it rather than using some internal system.
Yes, specifically what I was asking was, like, is there a this dot remove first found dot found sort of syntax?
Oh, can you get to a local variable of an internal function through this keyword?
Right.
You can't.
Okay. So, like, when you have a method that you can't change the return value.
Yeah, the programmer the developer of it would have to purposely make it so that you had some control over it. Think about it like in Unity, you have the public variables where you can change your speed or something like that up there. That lets you interject into that value. So the programmer would have to purposely give you a way in to that. Maybe it's a getter or it would be a setter, I guess. They would have a private global variable that they gave you access through a function, and then another function used that global variable. Okay, remove first found is going to take in a character. We're going to have a flag that's going to keep track of whether we've seen it already. We're going to build up our answer inside of answer. We're going to go through our entire string. If we are currently looking at the character we're looking for and we have not already found it, out of curiosity, how can I write that portion of that Boolean expression differently? My feeling is that most of you are pretty comfortable with looking at it that way. Even though the second half, the part I have highlighted there, you would very rarely see this written in professional development like that. It's actually a redundant statement. How do you want to say it? Just found? Well, we actually want to know when found is false. So, is this guy in and of itself a Boolean expression? Boolean expressions are expressions that boil down to a single value of true or false. If you forget about the and portion of this, will this guy, if found is true equal to false? Nope, that'll be false. If found is false equal to false? Yeah, that's true. How do I write that so that the result of that Boolean expression would be the same, but in a shorter way? Not found. You would say this. Not found. If the char I'm looking for is equal to C and the current value of found is false, because not found inverts it. Because the simplest Boolean expression would be either true or false, right? Just the solid value of true, the literal value of true, or the literal value of false. Not found is true when found is equal to false, because not false is true. Does that make sense? Now, pretty good bet at your part right now. Some of you are comfortable with this, but most of you like that better. It feels more understandable to you, even though I'm telling you that's not written the way you will often see it. In fact, it's actually redundant. This will be true if false is false. If found is false, this will be true when false is equal to false. And isn't false always equal to itself? So it's kind of a redundant Boolean expression, but it's not inaccurate. So what I'm telling you is that as a programmer, especially as a beginning programmer, or most of us are kind of intermediate programmers, let's say, write code that you're comfortable with. You're not trying to impress anybody. All right? If this makes more sense to you, if you understand this and you're a little foggy on this, write it that way. It's not incorrect. Just a little bit inefficient. We're not going to notice. That make sense? So for right now, I'm going to leave it like that because that is going to be more comfortable for most of you, I think. Is that a fair statement? That you like looking at it that way better than the not bound thing? Okay. Eventually, I do want you to get to the point where not found is just as clear as this. But for right now, let's not muddy the waters. Okay? So if this is the character we're looking for and we had not previously found it, at the very least, I'm going to say, I found it. So we're going to mark our flag as found. That way we don't do this logic a second time. Right? Now, what I'm actually doing here is I'm building a new string that should have everything in it except the first occurrence of the character I'm trying to remove. So rather than removing a character, I'm keeping everything but that character. But I only want to remove one element because this is my specialized tool, right? I'm going to find the next smallest guy the next time through. So I'll set found equal to true, and now what I really want to do is I want to move to the next iteration of this loop. Now, will that automatically happen as I have it written now? Right now, I'm doing one of two things every single time through this loop. I'm saying if I'm looking at the character that I'm looking for and I haven't previously found it, set found to true. Otherwise, go ahead and tack the current character onto my answer. Will this automatically, if I've done this logic here, will it always skip this logic? Yeah, an if and an else will never occur at the same time. The next time through, we happen to know, because of the nature of this Boolean expression, we happen to know that we will only execute this line one time. Correct? We know that. So every other time through here, we'll hit the else. Now, one thing we can do. We did introduce this last semester, but I'll review it right now. We actually have 3 keywords. I'm going to say, well, let's do loop keywords. That's what we're going to call them. One of them can be used outside of the loop. So our loop keywords, we'll do the special case one first, is return. So return, we can use that either within a loop. We can use return anywhere inside of a function, and it makes the function immediately end. Okay? So that's our power tool. If you want a function to die, say return. Function's over. Now, the other 2 are ones that are loop specific. One of them is called break. Remember what break does? What does break do? Breaks out of the current scope. That's actually probably more accurate than that's actually probably a pretty accurate description. For us, I want to think about it in terms of loops. It breaks out of the loop. In terms of language theory, what he said is actually more accurate than that. It does break out of the local scope, but it would not exit a function, but it would end the scope, which has all sorts of other problematic things associated with it. So in any case, break works with loops for our intents and purposes. And that's when you'll always see it. Nobody uses breaks anywhere else. It's inside of a loop. So if you're in the middle of a loop, let's say the loop was going to go through 10 times, and you've hit some sort of point in the third time through, and you decide, I need out. Okay, I've accomplished what I needed to accomplish in here. You break. And that jumps you past the loop, ignores the rest of the Boolean expression, and just gets you out of the loop and continues on following it. Okay? Now, the other one, which is the one we're going to use here, is something called continue. What does continue do? Pretty sure we introduced this last semester. Yeah, just skips this iteration of the loop. Okay? Now, we've said that in our current logic here, that will actually happen anyways. Because after this line, we'll hit the else. The else will not occur because we were already in the if, so we'll actually hit the end of the for loop here. But if we want to be more explicit about it, and it might help us kind of see it, all we're going to do the very first time that we see the character that we're looking for is we'll mark it that we've seen it, and then we'll continue. And what continue says is, do not go any farther into the logic of this function. I don't care what else is down there. Right now, we happen to only have an else. But you could have 5,000 lines down there. What continue says is, skip to the end of the loop and just go to the next iteration. Do I++. That makes sense? So again, this is overkill. It's an extra thing we don't need here because the logic would have naturally done this, but it also describes what we want to do. This effectively says, mark it as found and skip to the next time through the loop. Make sense? All right. So remove first found is going to go through. It's going to build up a new string, which has everything in it except the first dude that we found for the dude we were trying to match. And then what's it going to do? Before we exit out, we're going to set our internal string equal to our new, slightly modified version, slightly shrunk version of itself. That is going to be this dot s is equal to answer. That is, this dot s will be what it used to be with the char c removed from it, the first occurrence of char c removed from it. Good with that? All right, so we got two little tools here. So as long as s has stuff in it, we're going to find the smallest, then we're going to remove the first found of smallest, which should shrink that guy down. And what are we building here? We're building our sorted answer. So we'll have string, I'll call it sorted answer. This guy will start off as the empty string. So we'll find the smallest character in our string. Then we'll remove that from our string up top, but I've already preserved it inside of a character. Then I'll go ahead and add that guy, sorted answer is equal to sorted answer concatenated with smallest. So I'll go ahead and tack it on to my answer. We'll keep looping through over and over and over again until we finally have whittled s down to nothing. That is, we've removed every single character from s after first discovering the next smallest character in s. Make sense? Now, doesn't this while loop guarantee we will never call find smallest with anything smaller than a string with one element in it? That's why we didn't have to do the exception thing, because we knew how we were going to use our paper funnel. Make sense? But somebody else might fall victim to our function if they're not properly prepared for exactly how it works. Those are decisions we have to make as programmers. All right, so when we hit this point right here, after this while loop is done, sorted answer should have the sorted version of my string. And what will I do with it? I'll say this dot s is equal to sorted answer. I'll change my internal structure of s. Go out to driver. We'll put in hello here. we'll go ahead and do a system.out.println s, and it's going to print out superstring. What effectively happens in here? What's actually being called right there? It's almost guaranteed this is going to show up on the midterm. I've talked about it the last 2 classes. Println has a version that works on objects, calls its toString method. Yep. So this is going to call superstring's toString method, which we overrode to print out the string itself. All right, so this will print out hello. Then we're going to go ahead and tell our superstring to sort itself. And then we'll print it out again. So there's hello, and then there's our sorted hello. That makes sense? Okay, now, at the end of last class, I mentioned to you that if you were going to go and refer back to your notes from last semester, you might want to look at insertion sort, right? How many of you implemented this using insertion sort? Probably several of you. How many of you took more of a brute force approach to this, like we just did here? Did anybody do a merge sort? I would be impressed, but I was going to say hopefully not, because that's going to be a coming up assignment. But insertion sort is going to be a lot cleaner than this, right? I mean, the way insertion sort works, we're not going to have all these extra helper functions and things like that. We can actually probably write insertion sort here in less than 5 minutes. But was this okay? Did this run fast enough? Did we notice a slowdown? Did we have to remember the algorithm for insertion sort? Did we have to, well, forget about remembering the algorithm. Did we even have to remember the name insertion sort to go and look it up? No. We just decided, look, I could sort letters. I can sort characters. I'm just going to write my rendition of it. I'm an artist, right? So we wrote our own little thing. Yeah, it was kind of a, around the way of doing it, where we found a smallest, and then we removed that guy and just whittled it down until we ran out of smallests. Is this a pretty straightforward, easy to understand solution to this? Was this find smallest function? Is there anything overly difficult about that guy? That guy's pretty writable. Not the end of the world. We feel like we could all write that. If I gave you the homework assignment that said, take a string and find the smallest character in that string, that would be a relatively easy homework assignment, right? That was the only thing you had to write. Similarly, if we had the remove first found, if I gave you a string and a character and said, give me a string that has everything but the first occurrence of that character in it removed, would that be a relatively easy homework assignment? Yeah, not that bad. So we wrote 2 relatively simple algorithms, which then allowed sort, which we can say is a more complicated algorithm, to be fairly simple. Make sense? Now, if we were writing this as an insertion sort, public void insertion sort. Reality is the way I teach insertion sort is actually fairly similar to something called a selection sort. Bottom line is it doesn't matter what you call it, because frankly, the way I teach insertion sort, which is kind of a hybrid between insertion and selection sort, I actually think should be called bubble sort, which actually is a different kind of sort. Because the way I teach it is things bubble towards the top, right? Makes sense for that to be called bubble sort, but it's not. Whatever. So if we're going to write the insertion sort version of this guy, I would want to go ahead and get the character array version of it. Why would I want the character array version of my string? Why would that be beneficial to me? I can move stuff around, right? Strings, we can't change them easily. All right, so we can either write our own function to convert this guy into a character array. For instance, if we didn't know there was a toChar array function, we can certainly write private char array string to char array. Actually, we don't even need to say string to. We can just say toChar array because this guy already knows about the string. And then I'll go ahead and build a brand new char array that's the correct size. So I'll say char array AR is equal to a new char array, and I want it to be the same length as S. And then we'll go ahead and spin through S for I equals 0, I is less than this dot S dot length. I could have also said AR dot length there, because those guys are going to have the same length. We just built it with that in mind. I plus plus. Each time through, I'll say AR at bucket I is equal to S, this dot S dot char at I. And then ultimately return AR. All right, so in the event that we weren't sure that there was a toChar array built into the string class, was this overly difficult to write? No, not the end of the world. So hopefully what we're getting at with this is sometimes you can go ahead and remove some of the stress off of yourself when you're writing your code. And this only is going to help you practicing writing little widgets and stuff like this. If you're not sure something might be buried in the toolbox and you can accomplish what you need from the toolbox fairly easily with stuff that you know is in there, why not just write it real quick? Is this that big of a deal? That's fine. So now I'll just go ahead and say char array AR is equal to this dot toChar array. And there's the character array version of my string. Okay? The alternative is if I happen to know that strings have a toChar array, then I can say this dot S dot toChar array. And use the built-in tool that comes with strings for converting a string to a char array. Whatever. Pick your poison. All right, so there's our toChar array. Now, the way that insertion sort works is we start at bucket 1, and we bubble that element up as far as it can go until we shouldn't swap anymore. So we're going to say int pos is equal to 1 while we're actually going to have two different start pauses. If you remember from last semester, we have I'm going to have a start pause. We'll start that off at 1, and then I have a guy called the follower, and then we call that with the creepy name, the follower. Is that didn't I do the skeleton head in the slides last semester? Yeah, see, that stuck. All right, so that's our follower. So right off the bat here, we'll go ahead and say follower is equal to pause. Now we're going to internally follow this guy up the list, okay, as far as we can go. So over and over and over again, we're going to ask the question, is the guy that we're currently looking at, should he come before the guy before me? If yes, do the swap and follow. If no, we're done with this guy, move start pause to the next one, keep going. Okay, so what I'm going to do, let's stop here. We're going to finish implementing insertion sort on Tuesday. What I want you to do I'm not going to give you homework over break, but I want to give you a relatively small homework assignment for this weekend that is a modification of the assignment you did for this week. I want you to solve the sorting problem a different way than you already solved it. If you solved it with insertion sort, you're not allowed to use the exact solution I use, but you can use something like it. If you did it more like mine, do it in a different way. Either write insertion sort or write something else. Come up with a MacGyver approach to sorting. That makes sense? And if we're going to just change it just a little bit so you have a little bit different approach, why don't we just sort it in descending order this time? So instead of ascending, it's descending, just to switch the algorithm up a little bit. So it would be what? O, L, L, H, E. All right. All right. So no homework over no homework over break. You do have homework over the weekend for Tuesday because remember break starts Thursday. Next Thursday is
19th.
yeah. So we will not have class next Thursday. Correct? All right. Don't forget. Computer science get together right down the hall. Make sure you get there pretty quick, right before 11:30, so you can do the meet and greet thing and have a chance at the best, greatest prizes, blah, 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 and also get to meet your fellow classmates.
Now, if we extended that to 1 or